Hey guys, this is Samantha Stanley doing video presentation number 2. For this presentation, I'm actually going to go over number 19 of Unit 8.4, which in the 13th edition is trig substitutions. I actually really enjoyed this section. I hope that you guys did too. Trig relations and I don't really have a good understanding sometimes, but I found the substitution aspect to be really fun and easy to grasp. So Dana posted number 19 as a question on the thread, so I thought that I would go over it for my presentation. That way it'll help her out and it'll help you guys out as well. So number 19 is the integral, sorry about the really bad integral sign here, of x squared over the square root of x to the 6th plus 4 dx. So what's really interesting about this problem is it actually uses u substitution before it even does trig substitution. So if you've done 8.4, what's interesting about this problem is this is the first problem that actually, I think, uses u substitution before jumping into the trig substitutions. So I think that's why it was a little confusing. Like Dana, when I went to attempt this problem, I actually started out and I let x equal the cube root of 2 tangent of theta, and then by the time I substituted everything in, I got the integral of tangent squared times secant squared of theta d theta all over 1 plus tangent to the 6th of theta, and I think that it all works out to be the same in the end, to a degree, but not really, and it would involve some substitution, and I wasn't quite sure how to use, to do the substitution on an integral like that one. So, what I did to start this problem off is I let u equal x to the 3rd. I'm able to do that because powers of exponents, or the rules of exponents, says that x to the 3rd times x to the 2nd equals x to the 6th. And what I really need in my square root sign here is the x to the 2nd. Because x to the 2nd plus 4, we know how to substitute, do the trig substitutions for that. So what I've done is I've let u equal x to the 3, which gives me the derivative of u equal to 3x squared dx, and I solved it to be 1/3 du equals x squared dx, because I have an x squared dx in the numerator of the fraction of the integral. So that makes this really easy for me. So now I just brought the 1/3 out in front because that's a constant. It makes it easier for me to visualize. And so I have the du over the square root of u squared plus 4. Because if I substitute this x third into u, I get x cubed, which is u squared, and that'll actually give me x to the 6th. Because x cubed to this squared, is actually equal to x cubed times 2, which equals x to the 6th. So it's a little tricky, but makes sense in the end. So once I get this nice little integral here, we recognize that. We know what to do with that. So what I'm going to do is I'm going to let u equal 2 tangent of s. I used s because I don't want to use x. Gets things really confusing in the end, and when I have to go back in, makes it complicated. And then I take the derivative of u, which is going to be 2 secant squared of s ds. That's great because I have a du already in that integral. So what I do is I just substitute u and du in. So I have 1/3 the integral of 2 secant squared of s ds all over the square root of 4 tangent squared of s plus 4. Well, that's easy. We've done these before now. Sorry, this one's multiple pages as well, so bear with me. So I rewrote it here so you guys can see it. And I know that the square root of tangent squared of s plus 1 is actually just equal to the secant of s. That's easy enough. So I bring the 2 out because that's a constant, so I have 2 over 6, the integral of secant squared s ds, and then, like I said, we just put that in the numerator, do the substitution, and that's awesome because that just simplifies to 1/3 the integral of secant s ds. And once I integrate that, I have that it's equal to 1/3 natural log of tangent of s plus secant of s plus our constant. Well, that's great. And that's fine and dandy, but our original problem, as you remember here, was in terms of x. So I actually need to go ahead and use our trig here to figure out what secant of s is equal to in terms of u, and then once I do that, I can go back in and substitute x cubed for all the u's that I have. So it's pretty easy. And so I have my right triangle here, and tangent of s is actually, we already know sort of what that one is, because we have u is equal to 2 tangent of s, so if we just do a little algebra, we have that the tangent of s is equal to u over 2. Great, awesome. So if we do right triangle trig here, I like to draw my triangle, makes it more visual for me. I know that the tangent of s is equal to b over a. Well, b is always your y-axis, a is always your x-axis. So here we have a equal to 2, b is equal to u. Unfortunately, we also have to still solve for secant of s, and secant of s, according to right triangle trig, is c over a. So hypotenuse over a. So now what do we have to do? Well, we have to solve for c. So we have a squared plus b squared equals c squared, and if we do a little algebraic manipulation, we have that c is equal to the square root of a squared plus b squared. So here we have that c is equal to the square root of 4 plus u squared. Awesome. So secant of s is equal to c over a, or the square root of 4 plus u squared divided by 2. We're almost done. Bear with me here, guys. So I just wrote it out over here again. That's tangent of s is equal to u over 2. Secant of s is equal to that square root of 4 plus u squared over 2. What's great about these two fractions is we actually have a common denominator, so that makes it easier on us. I also wrote to remind us that u is equal to x cubed, since we did that a long time ago now. So in the end, we have that this integral is equal to 1/3 the natural log of u over 2, tangent of s, plus the square root of 4 plus u squared over 2, which is secant of s. And like I said, because it's a common denominator down here, I actually put everything over a common denominator. So once I plug in the substitutions for these tangent functions, I actually need to go back and plug in u equal to x cubed. And that'll finally finish this problem for us. And once I do that, I have 1/3 natural log of 1/2. That would be our denominator that I was talking about, times x cubed, or u, plus the square root of 4, plus x to the 6th, plus the constant. And that works out because we have 4 plus x to the 6th, and we can do that because u squared is actually equal to x cubed, squared, which is equal to x cubed times 2, I guess, in the exponent, which equals x6, which I explained a little bit earlier. But all in all, this problem was a little tricky. I know some of us had problems with it. I did too, but it makes you think that maybe you get in these habits of just jumping straight into trig substitution, but with this one, you actually had to do u substitution before the trig substitution. So it's a great problem for how to approach one of these trig substitution problems a little bit differently. So I hope that I was able to explain this to you guys. I know it was a little long, but I hope that you enjoyed it, and I'll see you next week.